Hello, everyone, and welcome to the second discussion on big data at Comcast. My name is Sean Reynolds, and today we'll be discussing dimensional modeling. This is an overview of what we'll be discussing today, particularly the voice remote and the high cardinality of the user input field in our data warehouse solution. Our team continues to build an EDM solution using the Mike schema and four-step dimensional modeling using Snowflake architecture. Firstly, our goal is to make queryable visuals with OLAP technology. Our bus matrix and dimensional design worksheet will be established with cross-functional support, meaning everyone is in agreement on specific terms and definitions in the bus matrix, and we will continue to evolve our EDM schema in 6-month intervals. With much of the Comcast machine learning and AI capability depending on the heavy use of dimensional modeling, we'll focus on implementing EDM schemas that support our iterative data model initiative. More about how we will iterate the EDM process later. Let's start with the four-step dimensional modeling. As described by the authors of the Data Warehouse Toolkit, a dimensional model begins at a high level. On the left-hand side, you'll see the flowchart of how a data model begins at preparation with a high-level dimensional model. Next, all detailed dimensions will be deployed. They'll be iterated and tested. The model will be reviewed by business users and validated, and the final design will be documented. The four-step process starts with considering the business process that the dimensional model will help to clarify. The first step to designing this model is to identify all of the business processes that are impacted by the fact tables and dimensions, and then declare the grain of the business process, meaning how small of a metric will your fact table help to evaluate. Next is to identify the dimensions and their attributes. During this step, an important consideration is to consult with business users across the enterprise to determine key features and terms that are understood and agreed upon. The last step at a high level is to identify the facts. We can use a dimensional design worksheet in order to help us determine where the source data comes from, where it's going, and how it's going to be used, including specific ETL rules. In order to properly document the design process when building a dimensional model, the dimensional design worksheet and bus matrix help to improve integrity. Also, new fact tables can be determined at a later date for new business processes that evolve over time. Our fact tables are comprised of data at the lowest possible grain and are normalized using well-defined primary keys. The example of the dimensional model shown on the right shows orders as the fact table and the dimensions surrounding that fact table in gray boxes. The grain is 1 row per order. In the case of the voice remote, it would be 1 row per inquiry. The metadata discussed next will help host teams with the ETL process. Next, we'll discuss the OLAP cube alternative that we've chosen to use, as well as the EDM schema. According to Microsoft, there are 2 types of semantic modeling: tabular modeling that uses relational constructs, such as tables, and multidimensional that uses traditional OLAP cubes. OLAP systems can perform extensive analytics without affecting transactional systems and have predetermined business logic that allows the end users to query data without knowing the underlying data structure. Multidimensional semantics in OLAP allow for analytics without affecting other transactional systems, or OLTPs. An alternative to an RDBMS is an OLAP technology called Apache Arrow, which allows for in-memory alternatives with data warehousing. And next, metadata is added to allow for iterative design with Mike 2.0. Mike, which stands for Method for an Integrated Knowledge Environment, has information development as the key concept. Information is developed as an application and is iterative in nature. In this sense, we will perform an incremental design process that develops information about each business process as an individual data application. Because it is iterative in nature, metadata can be added in post-production and queried later based on new business rules or processes in the blueprint architecture. In conclusion, to allow multiple pieces of metadata to be tagged to each user query on the voice remote, a Snowflake design will allow for many tables to represent one query, the many tables being the metadata and other tags that help us query the information at a later time. Although a Snowflake-type relational database doesn't work as a quick solution for machine learning, data models will be normalized using a user-friendly dimension and other metadata tags. Data investigation will allow our data scientists to understand user intent better and create new fact tables and dimensions centered around new insights. As the data sets grow and technologies are introduced to the machine learning field, the team can add new standards for how data delivery and reporting is conducted in BI. We thank you for your time and we hope you enjoyed the presentation. Thank you.